അല്ലേ? Okay. In the fourth module, we already discussed about the conventional energy sources and non-conventional energy sources, the different types of energy sources such as conventional energy sources and non-conventional energy sources. Then we are already discussed about the energy derived from sun, that is solar energy, and its applications and its uses, advantages and disadvantages. Then we were discussed about the fuel cell, constructions of fuel cell, working of fuel cell, and different types of fuel cell. Okay, now we want to study about the wind energy, the non-conventional energy source. The example of one of the example of non-conventional energy source or renewable energy source, wind energy. Okay. Okay. Wind energy. Wind is a form of solar energy. We already know that wind is a form of solar energy. Wind is caused by huge convection currents in the Earth's atmosphere driven by heat energy from the sun. We know that wind is formed by the action of heat energy from the sun. Okay, this means as long as the sun shines, there will be wind. Okay, we know that as long as the sun shines, there will be wind. Okay, winds are caused by the uneven heating of the atmosphere by the sun. The irregularities of the Earth's surface and rotation of the Earth. Wind flow patterns are modified by the Earth's terrain, bodies of water, and vegetative cover. This wind flow or motion energy, when harvested by modern energy, when harvested by modern wind turbines, can be used to generate electricity. Okay, we can generate electricity from the wind energy. Okay, we can generate electricity by wind energy by using modern wind turbines. Okay, how do wind forms? Typically, this begins with the sun's radiation, which is absorbed differently on the Earth's surface. The Earth's surface is heated differently because of scenarios like cloud cover, mountains, valleys, water bodies, vegetation, and desert lands. Okay. As a result of this uneven heating, there are bound to be Earth's surface that vary a lot in temperature. Air on surfaces with a high temperature will then begin to rise because it is lighter. As the air rises, it creates low atmospheric pressure. Air on surfaces with cooler temperatures sink. The sinking creates a higher atmospheric pressure. This behavior of warm gases or liquid moving upward and being replaced by cooler particle is called convection. The energy moving during convection is called convectional current. Okay. Do you know how wind is formed? Do you know that how wind is formed? Anusri, how wind is formed?
Miss,
വിൻഡ് എങ്ങനെ ഫോം ചെയ്യുന്നതെന്ന് ഐഡിയ ഉണ്ടോ?
അത് കൺവെക്ഷൻ കറൻസ്.
ഓക്കെ. എങ്ങനെയാണ് ഫോം ചെയ്യുന്നത്? സാധാരണ രീതിയിൽ പറഞ്ഞാൽ മതി.
അത്
അതായത് സണ്ണിൽ നിന്നുള്ള ഹീറ്റ് റേഡിയേഷൻസ് എർത്തിന്റെ സർഫസിലേക്ക് എത്തുമ്പോൾ എന്ത് ചെയ്യും? എർത്തിന്റെ സർഫസിന് മുകളിലുള്ള എയർ എന്ത് ചെയ്യും? ഹീറ്റ് ആകാനായിട്ട് തുടങ്ങും. ശ്രദ്ധിച്ചേക്കണേ. സണ്ണിൽ നിന്നുള്ള ഹീറ്റ് റേഡിയേഷൻസ് നമ്മുടെ എർത്ത് സർഫസിലേക്ക് റീച്ച് ചെയ്യുന്ന സമയത്ത് എർത്ത് സർഫസിലുള്ള എയർ എന്തോ ഹീറ്റ് ആകാനായിട്ട് തുടങ്ങും. എയർ ഹീറ്റ് ചെയ്യുന്ന സമയത്ത് ഈ ഹോട്ട് എയർ എന്ത് ചെയ്യും? ലെസ് ഡെൻസർ ആകും. അതായത് ലെസ് ഡെൻസർ ഹോട്ട് എയർ എന്ന് പറയുന്നത് ലെസ് ഡെൻസർ ആണ്. ഈ ലെസ് ഡെൻസർ എന്ന് പറയുന്നത് ലെസ് വെയിറ്റ് ആണ്. വെയിറ്റ് എന്താണ്? കുറവ്, ലൈറ്റർ ആയിരിക്കും. വെയിറ്റ് കുറവായിരിക്കും. അതായത് വെയിറ്റ് ലൈറ്റ് വെയിറ്റ് ആയിട്ട് മാറും. ഓക്കെ, ഹോട്ട് റേഡിയേഷൻസ്, ഹോട്ട് എയർ എന്ന് പറയുന്നത് ലൈറ്റ് ഇൻ വെയിറ്റ് ആണ്. ഓക്കെ, അപ്പോൾ ഈ ലൈറ്റ് ഇൻ വെയിറ്റ് ആവുന്ന സമയത്ത് അതിന് ലെസ് ഡെൻസർ ആയിരിക്കും, ഡെൻസിറ്റി കുറവായിരിക്കും. ഈ ഡെൻസിറ്റി കുറവാകുന്ന സമയത്ത് അത് എന്ത് ചെയ്യും? ഡെൻസിറ്റി കുറവാകുന്ന സമയത്ത് അതിൻ്റെ അറ്റ്മോസ്ഫിയറിക് കുറവായിരിക്കും, അറ്റ്മോസ്ഫിയറിക് പ്രഷർ കുറവായിരിക്കും. ആ പ്രഷർ കുറയുന്ന സമയത്ത് അതെന്ത് ചെയ്യും? ലൈറ്റ് വെയിറ്റ് ആയതുകൊണ്ട് തന്നെ എന്ത് ചെയ്യും? മുകളിലേക്ക് റൈസ് ചെയ്യാനായിട്ട് തുടങ്ങും. ഈ എയർ, അറ്റ്മോസ്ഫിയറിക് സർഫസിലുള്ള ഈ ഹോട്ടർ എയർ റൈസ് ചെയ്യാനായിട്ട് തുടങ്ങും, മുകളിലേക്ക് റൈസ് ചെയ്യാനായിട്ട് തുടങ്ങും. അപ്പോൾ ആ ഒരു സ്പേസ് വാക്വം സ്പേസ് ആയിട്ട് മാറും, ഒരു വാക്വം സ്പേസ് ആയിട്ട് മാറും. അപ്പോഴാണ് നമ്മുടെ പോളാർ റീജിയനിലുള്ള എയർ എന്ന് പറയുന്നത്, അതായത് പോളാർ റീജിയനിലേക്ക് സണ്ണിന്റെ റേഡിയേഷൻസ് കുറച്ച് മാത്രമേ കിട്ടുള്ളൂ, അല്ലെ? ഇക്വറ്റോറിയൽ റീജിയനിലേക്കാണ് കൂടുതലായിട്ട് കിട്ടുന്നത്, അതിന്റെ സർഫസിലാണ് കൂടുതലായിട്ട് കിട്ടുന്നത്, അല്ലെ? പോളാർ റീജിയനിലുള്ള എയർ എന്ന് പറയുന്നത് കൂളർ എയർ ആയിരിക്കും. അവിടെ എർത്തിന്റെ റേഡിയേഷൻസ് നല്ല രീതിയിൽ കിട്ടുന്നുണ്ടാവില്ല. അതുകൊണ്ട് അവിടെ ഏത് സമയത്തും നമുക്ക് ഒരു കൂളർ റീജിയൻ ആണെന്ന് പറയുന്നത് പോളാർ റീജിയൻ. അവിടെയുള്ള എയർ എന്ത് ചെയ്യും? കൂളർ എയർ ആയതുകൊണ്ട് തന്നെ ഹയർ ഡെൻസർ ആയിരിക്കും, അല്ലെ? നല്ല വെയിറ്റ് ഉള്ളതായിരിക്കും, നല്ല മോർ വെയിറ്റ് ആയിരിക്കും. അതുകൊണ്ട് തന്നെ ഹയർ ഡെൻസർ ആയിരിക്കും, ഭയങ്കര ഡെൻസിറ്റി കൂടുതലായിരിക്കും. ഈ ഹയർ ഡെൻസർ ഉള്ളത് കൊണ്ട് തന്നെ അവിടുത്തെ അറ്റ്മോസ്ഫിയറിക് പ്രഷർ എന്ന് പറയുന്നതും ഹൈ ആയിരിക്കും. ഈ ഹൈ അറ്റ്മോസ്ഫിയറിക് പ്രഷർ ഉള്ള ഈ കൂളർ എയർ എന്ത് ചെയ്യും? ഈ വാക്വം സ്പേസിൽ, ഇപ്പൊ നമ്മുടെ ഈ എർത്തിന്റെ സർഫസിലുള്ള എയർ മുകളിലേക്ക് റൈസ് ചെയ്തിട്ടുണ്ട്, ആ സ്പേസിലേക്ക് ഈ എയർ എന്ത് ചെയ്യും? മൂവ് ചെയ്യാനായിട്ട് തുടങ്ങും. ഈ കൂളർ എയർ ഹോട്ടർ എയറിന്റെ റീജിയനിലേക്ക്, ആ സ്പേസിലേക്ക് ഓക്യുപ്പൈ ചെയ്യാനായിട്ട്, മൂവ് ചെയ്യാനായിട്ട് തുടങ്ങും. ഈ ഒരു മൂവ്മെന്റ് ആണ് ഈ എയർ ഫ്ലോ, അതായത് കൂളർ എയർ ഹോട്ടർ എയറിലെ ആ സ്പേസിലേക്ക് ഓക്യുപ്പൈ ചെയ്യാനായിട്ടുള്ള ഒരു മൂവ്മെന്റ് ഉണ്ടാവും. ആ മൂവ്മെന്റിനെയാണ് നമ്മൾ, മൂവ്മെന്റ് ഓഫ് ദിസ് എയർ ഇസ് കോൾഡ് വിൻഡ്. ഓക്കെ, ആ മൂവ്മെന്റ് ഓഫ് എയറിനെയാണ് നമ്മൾ എന്ത് പറയുന്നത്? വിൻഡ് എന്ന് പറയുന്നത്. ക്ലിയർ? ക്ലിയർ? Okay. Then, as a result of this uneven heating, there are bound to be Earth's surface that vary a lot in temperature. Air on surfaces with a higher temperature will then begin to rise because it is lighter. As the air rises, it creates low atmospheric pressure. Okay, air on surfaces with a cooler temperature sink. The sinking creates higher atmospheric pressure. This behavior or warm gases or liquids moving upwards and being replaced by cooler particles is called convection or wind. The energy moving during convection is called convectional current. Okay, clear? In the diagram above, notice how cooler air falls, resulting in high pressure and moving towards regions of low pressure. Okay, when sun radiation reaches at the Earth atmosphere, the air at the surface of the Earth will get hotter and rise. Okay, and this place will become low atmospheric pressure. Then the cooler air with high atmospheric pressure will sink towards the direction of the low atmospheric pressure. Okay, this movement of air is called wind. Okay, then land breeze and sea breezes. Okay, land breeze and sea breezes. Okay, in the day when the sun is up, the land heats up very quickly and the air above it warms up a lot more than the air over the water. We already know that in the daytime, the sun, the radiations from the sun reaches at the earth, and the land space will heat up very fastly, very quickly. The land heats up very quickly, and the air above it, the water, the air above the water will heat slowly. Okay, the warm air over the land is less dense. Okay, the warm air over the land is less dense because the land is get heated. The low pressure is created. The air pressure over the water is higher with the cold dense air. At that time, the air pressure over the water is higher with the cold dense air. Okay, clear? Which moves to occupy the space created over the land. Okay, the The air over the surface of the land will rise because it is less denser. Okay, the this space over the land will occupy by the air with the cold dense air above the water. Okay, that means the air above the water surface will move towards the land surface. The the cold air, the cold air above the water will move towards the land surface. This moving of air from the water surface towards the land surface is called sea breeze, and it occur in the daytime. Okay, clear, clear. Any doubt? How land breeze and sea breezes are formed? Okay, in the daytime we get sea breeze, and the reverse is taken. The reverse is happens in the night. In the night, the reverse happens. The land quickly loses its heat. Okay, know that we know that the land quickly loses its heat, while the water remains its warmth. Water remains its warmth. So water slowly loses its heat. Okay, this means the air over the water is warm at the night. Okay, this means that the air over the water is more hotter than the air over the land at night. Okay, at night രാത്രിയിൽ കൂടുതൽ ഹോട്ട് ആയിട്ടുള്ളത് ഏത് ഭാഗമായിരിക്കും? Air over the water is more hotter than the air over the land. Okay, then low pressure is created over the water. Okay, uh, so the air over the water surface will have more denser than the air over the land surface. Okay, sorry, the air over the water will less denser, and the air over the land is more denser. Okay, then the air over the water surface will begin to rise, and the place where over the place over the water surface will occupy by the cooler air above the land surface. Okay, the movement, there is a movement, there is a motion of air, there is a motion of cooler air from the land surface towards the water surface. Okay, this movement of air at night from the land surface towards the water surface is called is called land breeze or offshore breeze. Clear? 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 Okay. Okay. In the daytime, we will get sea breeze, and the reverse will happen at the night. That is, we will get the land breeze at the night time. Okay. Then classifications of winds. Winds are classified according its speed. Okay, first one is calm air, that is light wind. The speed is 1 kilometer per hour. Then gentle breeze, gentle moderate breeze. Speed is in between 12 kilometers per hour to 20 kilometer per hour. Then moderate wind means speed is in between 20 to 38 kilometer per hour. Then strong wind means speed in between 62 to 74 kilometer per hour. Okay. This causes high waves over the seas and breaks off twigs and small branches from the trees. We know that. The strong winds. Okay. Then gale winds. It is the speed of the gale winds is in more than 75 kilometer per hour. Okay. They can very destructive, and they carry loads of broken branches and twigs from the trees. They cause high tidal waves and rolling seas. They can also rip off roofs of building. We already know that the varying speeds of according to the speeds of wind. We can classify the winds as calm air, gentle breeze, moderate winds, strong winds, and gale winds. Okay. Then, how wind power is generated? The terms wind energy or wind power describe the process by which the wind is used to generate mechanical power or electricity. Okay, the terms wind energy describe the process by which the wind is used to generate mechanical power or electricity. വിൻഡിൽ നിന്നും ഇലക്ട്രിസിറ്റി ഫോം ചെയ്യുന്ന ആ ഒരു പ്രോസസ്സിനെ നമ്മൾ എന്ത് പറയുക, വിൻഡ് എനർജി അല്ലെങ്കിൽ ഇലക്ട്രിസിറ്റി അല്ലെങ്കിൽ മെക്കാനിക്കൽ പവർ ഫോം ചെയ്തെടുക്കുന്ന ആ ഒരു പ്രോസസ്സിനെ, ആ ഒരു എനർജിക്കാണ് നമ്മൾ എന്ത് പറയുന്നത്, വിൻഡ് എനർജി അല്ലെങ്കിൽ വിൻഡ് പവർ എന്ന് പറയുന്നത്. Wind turbines convert the kinetic energy in the wind into mechanical power. We know that the moving air particles contains kinetic energy. Okay, moving object, energy of a moving particle is called kinetic energy, and energy of a static object is called potential energy. We already know that. Okay, then wind have kinetic energy because it is already always moving. Moving air, therefore the particles of the wind contains kinetic energy. Then the wind turbines will convert this kinetic energy into mechanical energy. Okay, the wind turbines which converts kinetic energy of the wind into mechanical energy. This mechanical power can be used for a specific task, or a generator can convert this mechanical power into electricity. Okay, this mechanical power then can convert by generator into electricity. Okay. Okay, into electricity to power homes, businesses, schools, and the like. Okay, we get the electricity by using wind energy, by the use of wind turbines and the wind generator. Wind and turbines will convert the wind energy, the kinetic energy of a wind into mechanical energy, and then it will convert, and then the generator will convert the mechanical energy into electrical energy or electricity. Okay. Then wind power. Wind power has been used as long as humans have put sails into the wind. Okay, humans are first sails into the wind. Sailboats are created for more than 2 millennia. Wind powered machines have ground grain and pumped water. Okay. Then there's an history for how wind turbines are created. There is no need for that. And Charles Brush's windmill of 1888 used generating electricity. The first windmill created by Charles Brush in 1888. Okay. Then onshore wind power and offshore wind power. Onshore wind power. Wind farms consist of many individual wind turbines which are connected to the electric power transmission network. Onshore wind power is a wind farm consists of many individual wind turbines which are connected to the electric power transmission network. Onshore wind is an inexpensive source of electricity, competitive with or in many places cheaper than coal or gas plants. Okay, comparative to coal or gas plants, the wind energy or wind farms are more inexpensive. Okay. Many individual turbines are connected to form wind farms on the land is called onshore wind power. Okay. Then there is a picture of onshore wind power, onshore wind farms. This is a wind turbine, and collection of these wind turbines is called a wind farm, and this is constructed on a land surface. Therefore, it is called onshore wind farm or onshore wind turbines. And the power generated from this onshore wind farm is called onshore wind power. Okay. Then offshore wind power. Offshore wind is steadier and stronger than on land, and offshore farms have less visual impact, but construction and maintenance costs are considerably higher. We already know that the wind farms are constructed on the water bodies is very expensive. The construction and maintenance are very costly. We already know that constructing a wind farm on a water body is very expensive, and construction and maintenance costs are very higher. Okay. Small onshore wind farms can feed some energy into the grid or provide electricity to isolated off-grid locations. Offshore wind power refers to the construction of wind farms in large bodies of water to generate electricity. Okay, we can generate large in much more quantity of electricity can be generated from the onshore wind power. Okay, onshore wind farms. This installation can utilize the more frequent and powerful winds that are available in these locations and have less aesthetic impact on the landscape than land-based project. It have less aesthetic impact on comparatively to the landscape and land-based project. Okay. However, the construction and the maintenance costs are considerably higher. The construction and maintenance costs are higher, but the aesthetic impact on the landscape is lesser than the onshore wind power. Okay. Then, world's largest offshore wind farm is the London Array with a capacity of 630 megawatt in United Kingdom, commissioned in 2012. World's largest offshore is situated in United Kingdom and it is commissioned in 2012. The name of the largest offshore in the world is London Array. Okay. Okay. There is a picture of a offshore wind farm. Here, this is a wind turbine, the collection of wind turbines from wind farm, and this is constructed on a water body. Therefore, it is called offshore wind farm, and the power generated from this wind farm is called offshore wind power. Okay. Then, onshore or offshore is better. The advantages and disadvantages of offshore wind power. A offshore wind turbine stronger than an onshore turbine. It lasts around 25 to 30 years and produces about 50% more energy than onshore turbine. When a strong wind blows, it produces around 3 to 5 megawatt per hour, higher and more constant wind speed. Okay. Then the disadvantages is, sorry, uh, the disadvantages of offshore wind powers are more expensive to build. The construction is more expensive and the maintenance costs are very much higher, more difficult to maintain and access. These are the disadvantages of offshore. Maintenance and constructions are very difficult. These are the disadvantages of offshore wind power, but the advantages are this is more efficient than onshore wind power. Okay, and it lasts around 25 to 30 years and produce about 50% more energy than onshore turbines. Okay. Then wind turbine. A wind turbine is a device that converts kinetic energy from the wind into electric power. Wind turbine is a device or machine that converts kinetic energy from the wind into the electrical energy. Okay. Wind turbines, like aircraft propeller blades, turn in the moving air and power an electric generator that supplies an electric current. Simply stated, a wind turbine is the opposite of a fan. Okay, we know that fan is a device which convert electrical energy into mechanical energy, whereas the wind turbine is a device which convert electrical energy into mechanical energy of wind into electrical energy. Okay, we can say that fan is an opposite device of wind turbine. Fan convert electrical energy into mechanical energy, while wind turbine convert mechanical energy into electrical energy. Okay. The wind turns the blades, which spins a shaft which connects to the generator and makes electricity. Wind turns the blades. Okay, we know that in wind turbine there are blades. Okay, there are blades. These are the blades of wind turbines. Blades. Okay, wind will make the blades to move or rotate. Okay, there will be a mechanical energy will be formed there. This mechanical energy is converted by a generator connected to the wind blades. Wind blades are connected to a generator. That generator will convert the mechanical energy into electrical energy. Clear? Clear? Okay. Okay. Then types of wind turbines. There are mainly two types of wind turbines are there, namely horizontal axis wind turbine and vertical axis wind turbines. Okay. Modern wind turbines falls into two basic groups. The horizontal axis variety, like the traditional farm windmills used for pumping water. We traditionally use the horizontal axis wind variety. That means horizontal axis. Ah, the picture is like this. The horizontal axis wind turbine. The horizontal axis of rotation is horizontal. Axis of rotation is horizontal. Okay. Horizontal axis. We traditionally use these kinds of wind turbines. Okay. Then the vertical axis design like the egg beater style or Darius model. This is all a vertical axis design is also called Darius model, named after its French inventor. It is invented by a French inventor. His name is Darius. Therefore, vertical axis model is also known as Darius model. The design of the vertical axis is just like an egg beater. Egg beater. You know that the egg beater. We use the beater for mm, beater egg beater, you know that the egg beater, the vertical axis design is just like an egg beater style. Okay. Large modern wind turbines are horizontal axis turbines. Most large modern wind turbines are horizontal axis wind turbines. Okay. Then horizontal axis wind turbines. Horizontal axis wind turbines have the main rotor shaft in an electrical generator at the top of a tower and must be pointed into the wind. Small turbines are pointed by a simple wind vane, while large turbines generally use a wind sensor coupled with a servo motor. Okay, and components. You study the components. There is a rotor shaft there and blades. Okay, most have a gearbox which turns the slow rotation of the blades into a quick rotation that is more suitable to drive an electric generator. There is a gearbox there. Gearbox will turn this, will speed up the rotation of the blades. There is a gearbox which speeds the rotation of the blades. Okay. Since a tower produces turbulence behind it, the turbine is usually positioned upwind of its supporting tower. The turbine blades are made stiff to prevent the blades from being pushed into the tower by high winds. Additionally, the blades are placed a considerable distance in front of a tower and are sometimes tilted forward into a wind a small amount. Okay. We only need to study the components. There is a rotor shaft and there's a blade and there is a gearbox in an horizontal axis wind turbine. Okay. The gearbox will speed up the rotation of the blades. Okay. Only need to study that. There is a figure schematic diagram of a vertical axis wind turbine. Okay. Then vertical axis wind turbine. Vertical axis wind turbines have the main rotor shaft arranged vertically. In horizontal axis, the rotor shaft is arranged in horizontally, whereas in vertical axis wind turbine, the rotor shaft is arranged vertically. One advantage is One advantage of this arrangement is that the turbine does not need to point it into the wind to be effective. In horizontal axis, designs, we want to point at the we want to point at the uh, blades into the in the direction of the wind. We want to point at the blades of the wind turbine towards the in the direction of the wind motion. Okay, but in the vertical axis wind turbines, there is no need to point it into the wind to be effective, which is an advantage on the side where the wind direction is highly variable. It is also an advantage when the turbine is integrated into a building because it is inherently less steerable. Also, the generator and gearbox can be placed near the ground using a drive from the rotor assembly to the ground based gearbox, improving accessibility for maintenance. Okay. The key disadvantages include the relatively low rotational speed with the consequential higher torque and hence higher cost of drivetrain, the inherently lower power coefficient. There is no need to study this. We only need to study the components and the arrangement of the components. Components are rotor shaft, blades, and the gearbox. The gearbox in the vertical axis design is placed near the ground, and the rotor shaft is arranged vertically in the vertical axis wind turbine. Okay. Then the advantages of vertical axis wind turbine is that there is no need to point it into the wind turbine to be effective. Effective. Okay. Then then, components of turbine. Wind turbine components are horizontal turbine components include blade or rotor, which converts the energy in the wind to the rotational shaft energy, a driven train, usually including a gearbox and a generator, a tower that supports the rotor and driven train. We know that a tower is there with which supports the rotor and drivetrain. Okay. Other equipment including controls, electrical cables, ground support equipments, and interconnection equipments, turbine configuration, wind turbine. You only need to study the components, blade or rotor, or drivetrain, a tower. Okay, and a gearbox. Okay, drivetrain usually including a gearbox. Gearbox is inside a drivetrain. Okay. Then general advantages and disadvantages of wind turbine. Advantages are wind energy is friendly to the surrounding environment. We know that wind energy is a non-conventional energy sources or renewable energy sources. Therefore, it is eco-friendly as no fossil fuels are burned to generate electricity from wind energy. Okay, wind turbines requires less space than average power stations. Okay, wind turbine or wind farm only need a less space to occupy. Okay, when combined with solar electricity, this energy sources is great for developed and developing countries to provide a steady, reliable supply of electricity. These are the advantages or merits of wind power. Okay, then disadvantages are the main disadvantage of wind power is regarding wind power is down to the wind's unreliability factors. In many areas the wind strength is not enough to support a wind turbine അല്ലേ? According to the area, according to the geographical structure of a land, the availability of wind is varying. Okay, that is a major disadvantage of wind turbine or wind power. Wind turbines, the second one is wind turbine generally produce a lot less electricity than the average fossil fuel power station. The efficiency of the wind power is lesser than the compared to the other power stations. Okay, which means that multiple wind turbines are needed to make an impact. Okay, the collection of wind power will make a smaller amount of current. Okay, there is a disadvantage of sorry, that is a disadvantage of wind power. Okay, clear? Clear? You have any doubt? You only need to study the components, how wind is formed, and the components of winds and land breeze and sea breeze, then types of winds, then a turbine, wind turbines, construction of a wind turbine, components of a wind turbine, and advantages and disadvantages of wind turbines. Okay, wind power. Okay.